You should study for my chemistry class. No, you did. I did bad on my chemistry.
All right. Shh. We're gonna talk about L-Hopper rule. L-Hopper rule is there is a indeterminate form. So indeterminate form has 6 forms. But there is two most popular form. Do you guys remember what's one of the most popular form that's indeterminate form? No one? Indeterminate form. You study it when back in the day, the limit. Well, sort of, yes. Yeah. Any indeterminate form that you already know. Okay, so you guys don't remember, but the first one is 0 over 0. It's not very difficult, but this is the one that's the most common occur. The second one is the infinity over infinity. So for the AB material is based on this indeterminate form. Now today I am going to talk about BC topics because I think when you talk about L-Hopper rule, you have to finish all the way, make sure the student understand all the aspect. So they are the indeterminate form. For example, 0 times infinity. And that's one weird one because you probably think 0 times infinity is going to be 0. But it's not true. So we're going to talk about that. 0 times infinity. That is the first odd one. The second odd one is actually 1 to the infinity power. You probably think that's 1. The first one you probably think is 0. But I will tell you it's neither. There was a 0 to the 0 power. And there's an infinity minus infinity. This case we'll get to tomorrow. Meanwhile, we're going to talk about first 5 cases of indeterminate form. Now for AB exam, you are going to have 0 over 0, infinity over infinity. But I'm going to show you that if it's an MCQ, so the question is a multiple choice. You don't need to show work. Don't need to show certain thing. The rubric. If FRQ, you must show rubric. And what I mean by rubric is because there's a certain way for you to answer the questions. If you don't, they won't give it to you. Now, every time, usually, there was students score perfect score on AP exam. They give you a certificate, they mail it to you. They say, hey, you got perfect. But in that particular year, when they first introduced L-Hopper rule, nobody got a perfect. No one got a perfect because nobody followed a rubric. So I'm going to show you the rubric. It's not from me. It's from a teacher from Boone High School. She's the one that showed me that you have to do this in order to get points. Otherwise, I would not know. So I'm very appreciated by her. So we're going to talk about rubric later. So what is the rubric later, right? But today, the main topic is this guy named, I have no idea how to spell his name. I'm going to try Gullaume L. And there's an accent mark here, L-Hopper. He's a mathematician. And mathematician is he studied calculus a lot, and he found out there was a way to find those limits. Okay, so now AP exam, they have spelled in the past, they have spelled as L-Hospital, And either one is fine because it's just different spelling. I have no idea. I don't know anything about French. So, but some student come back, tell me, says, oh, they have spelled it differently. And well, either one is acceptable, I guess. So what is El Hubble rule? It's going to be limits as x approach to c of f of x minus f of c. I'm sorry, g of x, sorry, g of x. If this is indeterminate, then you can look for the rate of the numerator, which is the prime, and g prime. So that means you can take a derivative of the numerator and take a derivative of the denominator. It's not quotient rule. Don't get confused with quotient rule. The quotient rule is low d high, high d low, low low. But here it's just basically asks you to take a derivative of the numerator, as it is, much easier, and then take a derivative of the denominator. And then when reach the c, you should get better evaluation. You should get better evaluation. What I'm trying to say is, this is a very useful for a lot of cases. A lot of people actually prefer this rule, but there is downside to this rule. We can talk about it later, but there is downside to this rule. But most of the time, El Hubble is very, very useful, very, very user-friendly. Okay, so again, you're going to take derivative of the numerator and derivative of the denominator and reach a value, get the same thing. So we're going to try the first case. And I'm going to show you the rubric now. So limits as x approach 0 of e to the 2x minus 1 over x. Now some people are just going to plug in 0 over 0 and they say like this. Oh yeah, this is 0 over 0. And this is just use El Hubble rule. But I will say, College Board, don't accept this. Don't accept it. You cannot just write down 0 over 0. You actually have to write out like this. So College Board will accept if you write out like this. You say limits as x approach 0, e to the 2x minus 1 is equal to, well, this one is going to be e to the 0 minus 1 is equal to 1 minus 1 equal to 0. So you can write like this, or limit x approach 0 of x, that's equal to 0. So you have this 0 over 0. You cannot just write down 0 over 0 like that. You have to write down the numerator approach to 0, denominator approach to 0. Then you can say, be it El Hubble rule. I can do limits as x approach 0, and I can take a derivative of the top, which is e to the 2x minus 1 over derivative of the bottom, x. So there'll be limit x approach 0 will be 2e to the 2x over 1. And if I plug in e to the 0, it's going to be 1. So 2 over 1, so the answer is 2. So answer is 2. So I just take a derivative of the top, which is chain rule, e to the 2x times 2. Derivative of 1 is 0. Take a derivative of x is 1. I'll reach is equal to 0 again. I get a value 2 over 1. See, now I got an evaluation. Now I want to show you in terms of graphing. If I were to put this in graph, this will look like this. It will look like e to the 2x minus 1 over x. Oops, my bad. Parenthesis over x, like this. Now you see this is just normal graph. It should reach 2, but pay attention. What happened when it reached 2? Yep, there's a hole in there. So it's not really defined. Remember a long time ago you studied rational function. If it's cancel factor, you're going to get a hole. In this case, you also get a hole, but there's no cancel factor. Because if you plug in 0, you're going to get 0 over 0. So the cancel factor is not definition of a whole. Is if you have 0 over 0, that should be a definition of a whole. It's also known as remove discontinuity. Now, with knowing this, I'm going to show you what AP exam question, how do they trick you? And you have to think a little bit more. Only a few people can think of these questions. I want you to try to think. And I won't tell you who's got a right answer. So even you got a right answer, I'm going to show motionless, like no motions. So approach equal to infinity of x to the 99 over e to the x. Let's see if you guys can figure out what will be this one as. X to the 99. Wow, that's a very huge number. And e to the x. Now, I want you to think about chess. Like, think about how you play chess. You don't play chess making on the next move. You basically plan out what happened a few moves later. Because you had to think about what people's going to counter you with, and you had to think a lot. So this question is more critical thinking questions. What do you think the answer will be? Now, the thing is, sometimes you can do L-Hopital rule more than once. So sometimes you get a number over number or 0 over 0 again. That means you can do L-Hopital rule again. And if it doesn't work, you can do it again. If it doesn't work, you can do it again. Again. But then you're going to find out something interesting about a bottom enumerator here. Anybody think they know the answer? If I keep on doing it, what will happen? Don't do it that many times, but if I keep on doing it, what will happen? Yes, Matthew. Okay, so what do you think the final answer will be? You have no idea? Okay, maybe Aiden can help out. It's a 1, okay, possibly, I don't know. Who else? Anybody else? Yes? 1, okay. Everybody agree with 1? Anybody have different answer? Luke, maybe you have different answer? Addison? No? Amber? Aria, what'd you say?
I think it's 1.
But what? But what?
It'll be 0?
Would it be 0? Possibly. Anybody else say 0 besides Ariel? And guess what? The answer is 0. Because I can do L-Hopital rule. Like, let's just imagine if I do it 1 time, right? It's going to be 99x to the 98, right? And e to the x, right? The top and bottom, it stay the same. And it's still indeterminate. This still indeterminate. And I can keep on going to another time. So be 98 times 98, x to the 97. And the bottom derivative is still e to the x. Still indeterminate. I can keep on doing it. Now, the goal is not ask you to do it. The goal is ask you to think about it. So x to the 96. So this is still indeterminate. So that means I can keep on doing it until it go back to constant. So what would it be on the top? Well, this is going to be a new notation. 99 factorial. Have you seen 99 factorial before? 99 times 98 times, sorry, this is 98, 97, 96, 94, 93, 90, and all the way go to 1 factorial and stop right there. So that's called 99 factorial. Yeah, so if you take a derivative of this constant, well, you don't need to take a derivative. Bottom still e to the x. 99 factorial is still a very large number. According to Ian, he says 9.23 times 10 to the 153 is basically very, very huge number. But however, that huge number compared to infinity still way undervalued. So on the bottom, it's still going to reach infinity. On the top, it's a constant. So that is still going to equal to 0. So the answer is equal to 0. Because the bottom is still, it doesn't matter what kind of derivative you take. So if you study a rate, at first that x to the 99 is always going to be e to the x. But eventually, e to the x will outtake x to the 99. Believe it or not, you know, it's just, you had to be a very large number, however, to do that. So yeah, that's one of the things that a lot of people need to know. So I'm gonna give you a couple questions, see if you guys can handle them. So the next one is, El Hospital rule says limits x approach the infinity of natural log of x over x.
Is that h over infinity?
No, that's just a number.
And then why would it be infinity?
E to the infinity?
Like,
Is
why
it?
is it
Okay, so imagine a graph. And I told you first day, this is a graph, is a very important graph. She's asking a very good question.
it's just a graph of e's essentially?
Yep, e to the x. If you keep on going up, guess where it's going? Yeah. If you're going to the left side, it's going to the 0 though. That's something that you need to know because that's going to be next question later. So what happened when limit x approach the infinity of ln of x over x? Well, ln of infinity is still infinity. Ln of x go to infinity is infinity, so it's still indeterminate form. So what do you have to do? Huh?
Oh, wait. It's not
So if you have write out, like I said, how to write out, I'm just gonna keep on writing until you actually write out properly. So you gotta write like this first, and then you can say, oh, okay, well, I can take a derivative. Unfortunately, that's how the rubric works in FRQ, and you have a test is rubric. So you have a test is gonna be based on FRQ rather than MCQ. In MCQ, I don't really care about writing down. So how do I know this is equal to 0? Well, think about it. 1 over 10, 0 0.1. 1 over 100, 0 0.01. 1 over 1,000, 0 0.001. Right? 0 0.001. So it gets smaller as number keep on increasing. So this is eventually go to 0. Does that make sense? So that way you know that happened. I show a lot more work. I just show the work what you're gonna expect in FRQ. In MCQ, they don't need to show work. You can just write down infinity over infinity, take a derivative top and bottom. You only need like 2 lines even at the most. So the next case gets kind of tricky. So what happened when limit x approaching negative infinity, not positive infinity this time? X to the x squared, e to the negative x. You're like, huh? What happened if I reach negative infinity on this specific case? remember, we're not approaching infinity, we're approaching negative infinity this time. So those are things that's slightly different. But the work is exactly the same. So, what do you guys get? So now limits x approaching negative infinity, that's going to give you 2x and negative e to the negative x. What happened if you reach infinity? Limit x approaching negative infinity of 2x is equal to negative infinity, right? Limit x approaching negative infinity of negative e to the negative x is still negative infinity. Because negative times negative is positive, so it's going to negative infinity. So in this case, infinity over infinity. So you want to take a d to the dx again. So limits x approach to infinity is here. It's going to be 2. And that's going to be e to the negative x. Now, remember, we are approaching negative infinity. So e to the negative infinity is going to be 2 over infinity. That's equal to 0. So that's equal to 0. I won't take a chance. I already based on math to prove it. I don't like to assume something. I know like when you come down to worst, I couldn't assume. But if it's not something I assume, I'd rather get a concrete answer. So for later on, like for example, Calc 2 today, their answer choice is basically converge and diverge, and maybe like absolute converge and conditional converge and diverge. So they have 3 options. But they have to show me the work how to lead to that, because you cannot just say, oh yeah, it's converge. I'm not gonna go by that because that's gonna be 30%. That's like a multiple choice. But you had to prove why they are converged and why they are diverged. That's a very, very important path. Yes, Amara? Yes, that's a great question. You're gonna stop and check. If you got a value, you stop. Actually, that's a great question. You got a value. If you got a value, if you don't get indeterminate form, you stop right there. And that's what the funny thing is, like this question. Limit x approach to infinity of, let's say, 6x to the 8 plus 10x to the square over 10x to the 8 plus 5x to the 3. If you reach infinity, in this particular question, guys, pay attention. In this question, if it's on the AP exam, I would not do L-Hopper rule. Because guess how many L-Hopper rule I have to do in this case in order to get a value, right? If I change this to, let's say, 7, you must take around 7 derivative in order to get a value. So what I will do in this particular case, I will actually divide it by highest degrees. And I will avoid L-Hopper rule. Not everything should be L-Hopper rule, especially radical or this particular case. I will avoid L-Hopper rule because in this case, you can say limits x approaching infinity of 6 plus 10 over x and the 10 plus 5 over x. This is going to go to 0. This is going to go to 0. So it's 3 over 5. So the answer is much quicker rather than L-Hopper rule. L-Hopper rule is not the best thing for many cases. This is one of the cases on AP exam that is a fact. A lot of students, they just keep on taking derivative until blindly, but you have to get a value, but you keep on not getting a value until you take a 7th derivative. which is that's not cool because I don't want you to take 7 derivative. And by that, it's very hard to simplify. So that's the trick about things. Like, not everything is always one way to solve a problem. Okay, let's do the other one. Limit x approach to infinity. I'm just going to go over as many different cases as possible. So this is negative x, square root x. Can you tell me which kind of indeterminate form is this one at first? And some people will say this is always the same thing, but it's not. So which kind of indeterminate form is this?
Could this also be e divided by exponent if you put the e on the bottom?
You can do that too. Depends on which kind. If it's numerator and denominator both have e to the x, I'll divide the numerator and denominator by e to the x, but not x squared over e to the x though. Because x squared e to the x, that doesn't work because e divided bottom, it's not. It's gonna get simple. You keep on looping back. Don't use chain rule because there's no chain. Well, hold on a second. It does have a chain rule on e to the negative x. I'm sorry. It's a very, very small chain rule, but it is true. But first of all, what kind of indeterminate form is this, right? If I will plug in infinity on this, e to the negative x, what would it equal to? E to the negative infinity. What's e to the negative infinity? No. Look at the damn graph. This is the first day I told you this graph's so important. What happened if you go to negative infinity? It becomes 0. So this is actually a 0 times infinity case. So 0 times infinity. Obviously, I cannot do L'Hopital rule here, so we had to make some manipulations. Algebra manipulations. Can I do this? What can I do? Put it in the x down. Yeah, now you can take a derivative. If I take a derivative here, that's going to be 1 over 2 root x. If I take a derivative at the bottom, it's going to be e to the x. That's going to be placed on the bottom again. Then when x approaches infinity, well, that's just going to be 1 over a very large number. That's equal to 0. So the answer is 0. I don't have to do too much work. Okay, you don't want to bring a square root x because that does not naturally happen, but you're gonna do that for the next example. But this is not natural example because you have negative x, you much easier to bring e to the negative x down, becomes positive x. That's more natural. The other one doesn't mean you cannot do it. It's more natural if you do it this way. Of course. You just convert from one indeterminate to the other indeterminate form, which is the main goal is to get to either. That's why AB only focuses on 0 over 0 or infinity over infinity, because that's the most essential one people have to convert to. If it's not there, you have to convert to there in order to use L'Hopital rule, because L'Hopital rule says it has to be a fraction. Now let's talk about the most well-known limits. Now, before I talk about this one, I'm going to talk about the things on SAT, which is you have coming up on SAT. It's called A equal to P times 1 plus R over N to the NT. Do you guys remember this equation? This interest rate equation. What does A stand for? A stand for future value. P stand for principal. R stand for interest rate. N stand for how many times it compounds. Okay, so how do you do it? Imagine if you have $2,000 and if interest rate is 8% and you deposit for 5 years with like compound semi-annually, compound semi-annually. So what you're gonna do is you're gonna plug in this, says 2,000. 1 plus interest rate is 8%, then you're gonna say 0.08. Because you cannot just type in 8 there, that's why it has to be a percentage. Semi-annually means how n is what? Not half, but 2. Because 2 times a year. So 2 times 10. And if you type in the calculator, it should give you a value what happened at 10th year. At 5 years, sorry. We say 5, right? So this is 5. So that will be the evaluation. Now let's speak of Mr. Ye decided to open a bank. We're going to call it Ye Bank. Okay, Ye Bank has a regulations. This regulation says, hey, you can only deposit $1. And you can only deposit for 1 year. But I'll even give you 100% interest rate because I'm a very generous person. Okay, so you can deposit $1. You can deposit 1 year, and you can have 100% interest rate. Even better, I'll give you. You can compound interest how many times you like. Doesn't matter. You choose. You can compound once a year, which is probably the least amount of money. You can compound 1,000 times a year. You can compound every second if all I care. Okay? So if I decide to do that, that means principal is 1 plus 1 over 1. That's if n equal to 1. If n equal to 1, it's going to be like this. And you can deposit 1 year. So that's going to be 1 times 2 is equal to $2. So after 1 year with 100% interest rate, Mr. Ye is going to give you back $2. Yes. Mr. Ye is going to go bankrupt if I have all his students deposit $1, right? No, I can afford a little bit. Don't worry. I got some money. N equal to 2. Then it's going to be 1 plus. Well, if you compound twice a year, you cannot do you cannot charge 100% interest rate. So that means the 1 need to divide it by 2 because that becomes 50% interest rate. Does that make sense? Because 1 had divided by 2, that's becomes 0.5. That becomes 50% interest rate. And you can only compound 1 year. In this case, this is going to be 1 times 1.5 to the 2. So it'd be 2.25. So if you compound twice, you actually earn another quarter. Do you see that? That's good. You just get another quarter. Now you cannot buy anything because of inflation. N equal to 4. You can do the same thing. 1 over 4 to the 4. And obviously you're going to get some type of value. But somebody work it out for me. Can somebody type in the calculator 1 plus 0.25 to the 4th power is? And not just say today, Mr. Ye says, I'll compound 365 days a year. So it'll be 1 plus 1 over 365. That means each day you're going to have 1 over 365 interest rate. And you're going to calculate 365 times interest per year. What would you get? Huh? 365. You have Cooper right now?
Cooper? I'm in this class.
Oh. I don't want to teach that. I will have to commit suicide before I teach that.
You don't like that?
No. My son literally asked me probability question yesterday on his virtual school. I don't know. I was like, look up organic tutor.
I don't know. Like, it's so different than calc, I feel like.
Okay, what'd you get?
2.7.
Okay, so we're gonna come back to that. Okay, So can you tell me what this one is? 1.25 to the fourth power? 2.44. Okay, so went up more and more and more, right? It's gonna go up a little bit more. So we're gonna come back to this question. Limit x approaching infinity of 1 plus 1 over x to the x power. Now, if I were to plug in limit x approaching infinity of 1 plus 1 over x, what do you think that is? Just focus on inside the parenthesis. What would it be? It's just 1, right? Because 1 over x is going to go, 1 over x is going to be 1 over infinity. That's 0. And the limit as x approach infinity is equal to infinity. So it's 1 to the infinity case. It's one of the indeterminate form that we don't know about. So now we're going to set this like this. This one's different than before because there was a exponent that is not a number. The exponent is an expression. So therefore, I must do something from before. On the last test, what do I supposed to do? How do I bring the x down? Natural log. That's why they're coming back to play. Natural log of y is equal to limits x approach infinity, x natural log of 1 plus 1 over x. Then you say, wait. This case is going to be limits x approach infinity of x equal to infinity, and limits x approach infinity of natural log of 1 plus 1 over x is going to be 0. Wait, this is an infinity times 0 case. That's still indeterminate, but this is not an indeterminate I want. So I must do some manipulation. Algebra 2 tells you this: x to the negative n equal to 1 over x to the n, or x to the negative n equal to 1 over x to the n. So, wait, are they the same? Oh, okay. 1 over x to the negative n equal to x to the n. I'm hallucinating, so don't worry about this one. Sorry about that. That's not the same, right? Yeah, that's not the same. So this is the thing. This x is in the wrong spot. I don't like that x. I'm gonna move it down. I'm gonna move it down to numerator. So move down. So it'll be ln of 1 plus 1 over x. And if I move down, what would it be? X to the negative 1. Good. So if we move down to the, that becomes x to the negative 1. That's the same thing as 1 over x, would you say? Now, I am in a fraction. I can take the L'Hopital rule now. D to the dx, d to the dx, because I'm in a fraction now. So remember, this is u prime over u. That's why you need to know very well on your last test. It's going to be 1 plus 1 over x. And the derivative of 1 over x is going to be negative 1 over x squared. The derivative bottom is the same thing, negative 1 over x squared. So limits x approaching infinity. So numerator, if I take a derivative, is u prime over u. Remember, this is a u prime over u. So I put a u on the bottom. I put u prime on the top. Do you understand? Okay, derivative of x to the negative 1 equal to negative 1 x to the negative 2. That's equal to negative 1 x to the 2. So that's how I get this. If I take a derivative inside, it's going to get negative 1 over x squared. But you use the u prime over u case. Yes, yes. Now those two going to cancel out nicely. Boom, boom. That's equal to limits as x approach infinity of 1 over 1 plus 1 over x. You guys already know that. What is that equal to? This is 0, so it's going to be 1, right? Because this part is equal to 0. So it's 1. So is my answer 1? It's not 1. ln of 1 is equal to 1. Okay. So can you type in the E value in the calculator What does that show? 2 point what? 718, right? 28, right? Guess what? Mr. Ye's bank, if you do 1 plus 1 plus 1 over, okay, let's do it. 365 days. And each day has 24 hours. And each hour has 60 minutes and 60 seconds. That's how many times it compound. To the 365, to the 24, to the 60, to the 60. Can somebody tell me what the value is? No. Go type in. Look, can you type in? You know, you're really fast on that. So I'm going to compound every second. Mr. Ye decided to be very, 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 very generous for you. He says, hey, you can compound infinite time. You not bankrupt me. So it's 1 over 365, 24, 60, 60. Using decimals is probably faster. Two 2.7. Give me like 3 decimal places. And type in the value of E. Just type in E in the decimals. Just type in E. 2.718. So this is a natural number. Now remember, a long time ago, you also learned something. How do you get E? Somebody mentioned that. P-E-R-T. Do you remember E? This is a compound continuous. And this is where the E come from. P-E. That E is 1 plus 1 over x to the x. And this is definition of E. So definition of E is limit x approaching infinity of 1 plus 1 over x to the x is equal to E. This is a definition that you guys just discovered. How much time I have? 6 minutes? Okay. We didn't talk about 0 to the 0 power. In my old class, we talked about this. In my pre-calc class, that's the first lesson. 0 to the 0 power. Remember 0 to the 0 power, your teacher says is equal to 1. And some people says 0. But which one's true? Right? We're going to use calculator to prove this. So we're not going to illustrate anything. So what we're going to do is we're going to approach 1 to the 1 power, approach 0 to the 0 power. So I need somebody's help. Those are people who are very good with calculator, which will show you how it works. So if I do, instead of going, we're going to approach both number equal to 0. So what we're going to do is 0.9 to the 0.9 power. Can somebody type in 0.9 to the 0.9 power is? Give me 3 decimal places.
0.910.
Okay. What about 0.8 to the 0.8 power? 0.837. How about 0.7 to the 0.7 power? 0.6 to the 0.6 power. So what does the trend go into? What do you think? Is it going to 0? Approaching 0? Or somebody have broke math? Right? It's approaching 0 if I'm going towards 0, right? So let's do 0.5 to the 0.5 power is? 7.07. Now, do you guys see the number? Do you see the pattern is worth concern? Is that going towards 0 or no? Yes? But do you also pay attention to the output as has changed slightly each time? Oh, bigger decrease at first and then slower decrease at later, right? What is that called? Concave what? Up, good job. 0.4 to the 0.4. The 0.3 to the 0.3. Oh shit, it's turning around. The ship is turning around. Maybe math is right. 0.2 to the 0.2 power. 725. 0.1 to the 0.1. 0.01 to the 0.01. It's turning around. The proof, the math is coming back. Okay, it's 4 zeros. This is probably close enough. 9, 29 or 19? Yeah, so it's pretty close to 1. So it actually turned around. Now, if you pay attention to the graph, this is the graph that you should see. This is x to the x graph we never studied before. It going like this and turning around. Turning around. Okay, yes. Yes. Yes, they are. Not telling you.
What?
Not telling you. Not telling you. There's a reason why I'm not telling you, though. Huh?
Is it a secret?
No, it's not a secret, but I'm just not telling you. How about you go discover it? I know the answer. No. Okay, so this is another question that you had to do before in the class. If you don't, I'll send a picture of you just to show you, but I'll send a picture to send. So limit x approach to 0 from the positive sign, sine of x to the x. Now, I just went over most of the indeterminate form, except 1. We're going to talk about that 1 tomorrow. And then you should have including your differential equation with L'Hopital rule. Now, I'm going to show you some AP exam as well today. I haven't found one yet, but I'm going to find a couple. But I'm going to go print out BC test before they kill me.
Go, run, run, run. I kept smiling because I was like laughing in his face. You can't really take the derivative once you. I swear you throw left. Oh. I'm ready to.
gonna be long since. Yeah. Might be long. Say you're 10 minutes into lunch. Why are you worried? You know your P theory? Yeah, P theory. You're fine. 25% of 10. Make sure you know the names of all the theories.
Senior, I thought it was like there. Not much.
5.232. He's gonna want to calculate L. He's gonna want to calculate L on 2. Now tell me what we got to do with the EU. They did. We got or at least that was like a report. Have you made? Have you been here? Or did you just get here? I'm excited that he's gonna go print out. Oh, this for every big code day, bro. Yeah, so he didn't beat me. Right? Yeah, we got that last. Alright, let's see. Rob. Was Rod not here? Bro, Rod's actually dude, it was already bad. And he had one day to make up like 80 assignments.
Not accepted in the college and has not come back.
I asked him on one day, finally showed up. I was like, that back there, like, what bad hours. Last night. I saw that on Purple Live. I was like, beyond 30 minutes. I almost asked on my screen.
It's like, oh, 1.5 right now.
You sure?
Yeah, you completely should run. Then you're supposed to like justify it where we have to like write down, oh, blah 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 equals this because whatever.
Well, if you use it in tests, I like so for like AST, you have to show like why is converged. You have to tell me the reason. So that second page that you can tell, that second page, they will tell you which test you had to use, what to work the company with it, and the converge or diverge. It's very intuitive. And then I didn't give you a really hard question, so I give you like as simple as questions I can think of.
What we got?
I mean, I can give you a harder question.
I can do the first one.
I mean, this is the first time you see ratios, right? Now for question 3, the sum that you're gonna get is not exact sum. That's the only thing I can tell you. Okay, so but they did tell you restriction, what you cannot use comparison or limit comparison test. But there's only 2 ways to find the sum. So wait, 2 or 3. 2 ways to find exact sum. 1 way to find closer to the sum, but it's not exact sum. I have no idea what I'm talking about. I'm dumb. Richard here.
No.
A bastard.